Okay, so in exploring inductive definitions, so like this one, un plus 1 is 0.2 times un plus 10, where u1 is equal to 8, we can actually come across some quite strange behaviour. So you might want to try this out for yourself. So get a calculator and type in the number 8. Press equals, okay? So if we try 8 and then press equals, okay? And then you want to do 0.2 times by the answer key, then plus 10. Okay? And then press equals again. So 0.2 times the answer key plus 10, press equals, you get 58 over 5. Now just keep pressing equals, okay? If you keep pressing equals, you should eventually find that we get to the value of 12.5, okay? 12.5. So now what I'd like you to try is, instead of trying 8, let's try the number 2. Okay? Let's try 2. Do exactly the same process. 2 then equals, then 0.2 times the answer key plus 10, and then keep pressing equals. And what you should find is that once again we come across this number. Okay, so maybe that was a fluke. Maybe we should try the number 2000, for example. Okay, so if we try 2000, how about that? 2000, then press equals, then 0.2 times the answer key plus 10. Then just keep pressing equals. And once again, you should find that eventually, after pressing equals enough times, you come across 12.5 again. Okay, let's try it with let's try it with a negative number. Let's try minus 11. Okay, surely that can't be the same thing. So minus 11 equals, then 0.2 times the answer key plus 10, and we're going to keep pressing equals there. Oh well, that's going towards 12.5 again, okay? So what we're finding is that we can choose any number we like, and the sequence is converging upon this number, this 12.5, okay? So why is this happening? Well, what's happening in the background is that as we're putting numbers in, okay, so if I, let's say we start not with minus 11, let's say we go back to the number 8, okay? So u1 is 8, and then u2, okay, is 0.2, so 8, then 0.2 times the answer key plus 10, and that gets me 58 over 5, so 11.6, okay? Then u3 is equal to 12.32. Then I get u4 is 12.464. And then I get u5 is 12.4928. And then u6 is 12.49856. And let's go a couple more. So u7 is 12.499712, and u8 is 12.4999424. Okay, so I'll leave it there. So what we can see, okay, is as we go through this sequence, what is happening is that the gaps between these numbers are getting smaller and smaller and smaller. So effectively what I'm saying is the numbers are getting closer and closer and closer together. So what we're finding is that this number here, this number that I'm putting in, is getting closer and closer and closer to the number that I'm getting out. Okay? So un is getting closer and closer and closer to un plus 1. So let's say that eventually we reach the point where un and un plus 1 are identical. Now this won't happen, okay, if I choose any value other than this number, this won't happen. But we can get as close as we like. So let's say that the number that I'm putting in is L, okay? So the number I put in is L, and the number I get out, consequently, is the same, and so that is also L. So I've replaced the un plus 1 and the un with L. L for limit, okay? And this gives me an equation. So I can take 0.2L from both sides, and I get 0.8L is equal to 10. And then if I divide both sides by 0.8, 10 divided by 0.8, okay, do that on the calculator, is 25 over 2, which is 12.5. Okay, so we could use this technique to find the limit of this inductive definition. So this is one of the curious things that comes from inductive definitions and these sequences, where some have this limit. Not all of them do, okay? This won't work for all inductive definitions, and is really given by that 0.2. That's what allows this to happen, okay? But it is a curious thing that is working in the background that is well worth knowing.